All right, good afternoon. So moving on, we started with simplifying rational expression on the prior lesson. Now we're going to talk about multiplying and dividing rational expressions. Now, for the most part, we're not going to be really multiplying and dividing in the very beginning. We're going to do a lot of simplifying first before we actually multiply anything. And the reality is we don't necessarily divide rational expressions either. We simplify them down and then really multiply when we get a chance to, okay, if we can. So when we talk about simplifying in the prior lesson, we talked about being able to factor out a GCF if possible, to factor a difference of squares or a trinomial, okay, where a is equal to 1, okay, and then simplifying means we were going to actually reduce or in some way, in some terms, cancel out terms. Okay. So the idea of multiplying and dividing is going to be kind of like this. We have a term here, and we're going to multiply it by another term. But in order to do so, what we're going to actually do is create the factors for your numerator denominator first by either GCF or by different squares or by trinomials. And then we're going to use the idea of reducing or canceling terms where we can, okay? And so when we do this, we're looking at this, we're not looking at just this part only, we're looking at it as a whole. So in other words, if I see the factor that this is an x minus 9, and I have an x minus 9 over here in this denominator, I can actually reduce those or cancel those out as such, okay? And again, if I look here, I have an x plus 1 right here and an x plus 1 right here. I can reduce or cancel out those terms like that. And so what we're actually doing is we're actually going to multiply just the remaining terms if we can. So like here, we're not going to do anything with this x minus 5. It's just going to stay the way it is. And we're not going to reduce x's this way. We're not going to reduce 10 divided by 5. We're not going to do any of that. We have to make sure we treat it as it's one term, one factor. So we cannot reduce this x minus 5 unless we have another one that's exactly the same in your numerator. But what we are going to do is we're going to go back to our old friend of multiplying these terms, where we go, if we do x times x, which is x squared, x times negative 10, which is minus 10x, 2 times x, which is 2x, 2 times negative 10, which is minus 20, so that our final answer is going to be x squared minus 8x minus 20, and then x minus 5 on the bottom. And we have our multiplied expression. Okay, that's what we're going to be doing. So let's kind of review what simplifying is one more time and what factoring is one more time. Okay. If I have this term right here, this is the difference of squares. And that basically means I'm going to end up with two factors where this is square root to both terms. So square root of x squared and square root of 4 becomes x plus 2, x minus 2, kind of like that. The bottom part is going to be it's going to be a GCF. It's going to be a GCF of 2 because I can divide 2 into 2 into 4. So I would have 2 where I have x plus 2 remaining. And then because I have x plus 2 and x plus 2, I can reduce those out. And then for my final factor is x minus 2 over 2. Now, I'm not going to reduce these because this is a factor term versus a constant value. Okay, so we leave it as is. The other thing that we've worked on are trinomials. And trinomials, again, you can do the T-chart thing that I've kind of worked with before. But, I want to have a negative 5. What'll give me a 5? Kind of this way. Or if I do 1 and 5, which is the only one since it's prime. But I need to get a positive 4. So I make this a negative 1 instead. So that way my factors would be x minus 1 and x plus 5. And then I do the same thing on the bottom. I need a 2, which again, 2 is prime, so I do 1 and 2. But I need a positive 1 in the middle, so the only way to do that is to make this 1 a negative. So that way I end up with x minus 1 and x plus 2. And again, the same rule applies. If I have two factors on the top and numerator denominator, I can reduce or cancel those out, so that my final answer is just going to be my remaining pieces. Okay, so that's the factoring that we've done to do this. Okay. So now, what exactly are we looking at? Well, first of all, we'll talk about multiplying. I'm going to see if I can get this to cooperate today. So when we multiply, again, we're not going to necessarily multiply this term to this term. What we're going to do is we're going to factor these two out, reduce, and then multiply if we can. So, again, I look at this and I say I need something that gives me 8, which, 4 and 2 is the most common one. But I need to get a positive 2 in the middle with a negative 8, which means I need to make sure that this is a minus 2 like this. Okay. And so if I rewrite this, this becomes an x plus 4 and an x minus 2 over. This is the difference of squares because it's x squared minus 1 and 1 is a perfect square. So that means I square root both of those terms. X plus 1, x minus 1. And then these are both already prime factors, so you can't really reduce those or factors out in any form or fashion. So I'm just going to rewrite those as my second terms. Kind of like that. Okay. So now I can multiply through. Well, again, I can reduce, cancel those two right there. I can reduce, cancel those two right there. So my final term is just what I have left over right here. So this is going to actually be equal to x minus 2 over x minus 1. And I actually didn't have to multiply anything. And that's it. We don't reduce these x's because it's two completely different things, or part of two different factors, so we don't mess with them. Okay. And that's what multiplying a rational expression actually does. Okay. Notice there really wasn't any multiplying involved. It was mostly just simplifying and factoring, reducing out. So dividing kind of follows the same rules. So, except we don't really ever divide. We multiply by reciprocals. Okay. Multiply by reciprocals. Okay. So here's what we actually do. We take this, and this x plus 3 over x minus 5 doesn't really do anything. But we're going to multiply by the reciprocal of this. And that basically means I'm going to do x squared minus 25 over x squared minus 9. So we're not really dividing, we're actually multiplying by the reciprocal instead. Then I can take this and I can change it into factors. Well, this is the difference of squares again, which means this can become, and I'm going to write this up here now, x plus 5 and x minus 5. Difference of squares right here. So I can make this become x plus 3, x minus 3. And now I can reduce if I can reduce and all that. So like this x plus 3 reduces this x plus 3. This x minus 5 reduces this x minus 5. So my remaining factors of x plus 5 over x minus 3 is all I actually have left over. And that's the idea of dividing and multiplying rational expressions. It's just that. Factoring and reducing wherever we can. So, how do you know when to do what? Well, it's pretty straightforward. The problem's going to tell you where you multiply and divide. Okay, so here's 5 and 6, if it ever focuses like it's supposed to. I would try them first, and then I'll come back here with the answer to try and show you what to do. I will tell you this. This x plus 2 right here, we treat it as a fraction of x plus 2 over 1. That I will tell you. Okay? Anyway, try it, and I'll be back with the answers. All right, so here's example 5. Again, this was a GCF term. So you know what I did? I was able to reduce the x plus 2 and the x plus 2, which left me with 5 over 2. So my answer was just 5 over 2. 6. Same thing. This was a GCF term. So was this. Division, which means I have to make sure and flip this to reciprocal of 3 over 2 x minus 20. GCF of 2 out to make this x minus 5. GCF of 2 out on this one to make this x minus 10. Now, when you reduce, you don't always have to reduce factors. You can reduce numbers. So like here, this 3 actually reduces this 3 out. And this 2 reduces this 2 out. So that gives me an x minus 5 with an x and an x minus 10 here. So I multiply these two back. That gives me x squared minus 10. And that would be your factor term. Okay, here's try 7. Try 7. Okay, and 8. Hold on, let me pull 8 up here so you can see both. And then I'll be back here with what you did. Okay, I'll give you a hint. This is a trinomial. Matter of fact, all 4 of these are trinomials, so we're going to have to do some factoring. This is the difference of squares. That's a GCF. That's a trinomial again. And I apologize for my camera not focusing like it's supposed to. All right, so here's example 7. Again, I did all my multiply, so negative 6 and 5 gives me negative 30 and gives me negative 1 right here in the middle. 5 and 2 give me 10 and a 7 in the middle. Negative 3 and 2 gives me a negative 6 and a negative 1. Negative 7 and negative 6 gives me a positive 42, but a negative 13. So then I write all my factors based on all that. And then I'm able to reduce x plus 2, the x minus 6, the x plus 5. So all I'm left with is x minus 3 and an x minus 7. 8. Okay, this is difference of squares. So that becomes 2x and 3. So 2x plus 3, 2x minus 3. This 25 is a negative 5 and negative 5 because I needed to give me a negative 10 in the middle. So x minus 5 and x minus 5. Division means I flip it to reciprocal of x minus 5, 4x minus 6. This is a GCF of 2. That gives me 2x minus 3. I can reduce out, reduce, reduce. And just so that you understand, if I only have 1 in my numerator, I can only reduce 1 in my denominator. So this one's still safe. I have left over 2x plus 3 here. This 2 still is here. And then x minus 5. So then I multiply back the 2 to get 2x minus 10. Okay. 9 and 10. Last 2 examples. And again, I'm going to kind of give you a heads up on how to do these. So you can kind of see them before you try. I mean, at least try. It's funny, my camera looks straight, but when I look at it on this side, it doesn't look like something. Right, but anyway, okay. So trinomial, difference of squares. Actually, it has a GCF also. Okay. Difference of squares. GCF, nothing. Okay. So again, try them. I'll be back here in a second with the answers. All right, here's example 9. Again, 4 and 4 gives me 16. It also gives me 8. 4 and 2 gives me 8 and 6 in the middle. Here, I have a GCF of 16, which means it gives me x squared minus 4 if I do that. This gives me difference of squares, which is going to be 4 and 4. So 4 and 4 from this one right here. 4 and 2 from this one right here. This is difference of squares, square root. So it gives me x plus 2x minus 2. Difference of squares, which gives me x and 4. So x plus 4, x minus 4. Cancel the plus 2, plus 4, plus 4, plus 4, plus 4. So there it is. I have 1 here, I have 1 here. So I can reduce both of these out with those. So all I have left is the 16 and this x minus 2. and then this x minus 4 in your denominator. If I multiply these back, that gives me 16x minus 32 over x minus 4. Okay. Example 10. Again, this is a lot of GCFs on this one. First thing I did was flip my reciprocal down to where it's x plus 10 over 10 instead. And the other thing I'm going to tell you is you cannot reduce these out because this is a factor term. This is just a constant. You cannot reduce these out because this is a 40x and a 40, and we're still adding. You treat this as one item. The GCF on top is 10x, and that leaves me with x plus 4 on top. The GCF on the bottom is 4. That leaves me with x plus 10 on the bottom. This doesn't change any. I can reduce out. This 10 can reduce this 10 out. That leaves me with x and x plus 4 and a 4 on the bottom. I cannot reduce these because it's a factor term versus a constant. But I can multiply these back to where it's x squared plus 4x over 4. And there you have it. That's multiplying and dividing rational expressions. Okay. So there you have it. You have a good evening.